For my educational video, I chose to talk about two different types of chemical reactions, which are combustion and decomposition reactions. Here's a little review of combustion. Is when an element or compound reacts with oxygen, often producing heat or light. And decomposition is when a single substance breaks down into two or more simpler products. These can be easy for me to remember, but it's harder to apply these ideas to actual real-life situations where you see them happen. The situation I choose to talk about are diesel engines, which are also internal combustion engines. So obviously we're talking about combustion here. This is where the engine will convert chemical energy into mechanical power, which is the mixture of fuel, diesel fuel, and oxygen. In the ideal, in a perfect world, the internal combustion process would only produce carbon dioxide and water vapor and unused engine air as products. But this isn't always the case. There are other factors, and many common factors, that can contribute to less than ideal situations. That would be unburned fuel vapors in the air, reactions between mixture components under high temps and pressure, which are changeable in diesel engines. You can adjust those. Combustion of engine lubricating oils and additives. Combustion of non-hydrocarbon components of diesel fuel, such as sulfur compounds and additives. So these extra factors create emissions that aren't ideal. The reactants versus products. The reaction of internal combustion engines is the diesel fuel reacting with oxygen, which is combustion. As straightforward as that sounds, the less than ideal situations can sway the actual reaction to product formula. So there's not always a set chemical formula for both. Products of ideal combustion aren't hazardous to our health or the environment. CO2 has greenhouse gas effects, but that's common. The other situations are hazardous, and regulations have been set in place to limit the hazardous products released from diesel engines. Products of less than ideal combustion reactions are in the form of unburned hydrocarbons, carbon monoxide, and nitrogen oxide or particulate matter. Nitrogen oxide, or NOx, is very toxic and is a respiratory irritant to humans and other animals, and can cause different types of damage to vegetation, which then affect oxygen levels, and this is through the ozone. Intro to DEF, DEF, diesel exhaust fluid, whatever you want to call it. Since 2010, most diesel engine vehicle manufacturers are required to have a system in the vehicle that monitors and reduces hazardous emissions, which are the products of less than ideal situations in internal combustion engines. A very common way to do so is by adding DEF into the diesel exhaust before it enters the air. This reaction can produce almost near zero levels of harmful emissions, and then that is just kind of like a little block showing the evolution of diesel engines and their emissions throughout these years, where 2010 was projected to be the least of all of these. Engines, from 2007 on, they weren't required to add DEF to the engines, but there were extra systems set in place to reduce through filtration. DEF continue. Diesel exhaust fluid is made up of a strict aqueous solution of deionized water and high purity urea. This is injected upstream of a catalyst in this situation, which is the catalytic converter, where it vaporizes and becomes ammonia and carbon dioxide. During that process, ammonia is the main substance that is needed. That reacts with the harmful NOx in a decomposition reaction and produces harmless N2 and H2O. And this is a more in-depth visualization of this reaction. To the average diesel user that requires a DEF system in place, your DEF levels will fluctuate, how quickly they go down depending on the engine load of a vehicle. The systems are made to detect the amounts of certain emissions that need to be adjusted with DEF, and those systems will inject based on how much load your engine is under. You add the DEF into a separate tank meant for DEF, never add it straight to the fuel. It comes in different types of containers, and even gas stations are starting to have DEF pumps. Just FYI. Where you actually see it and might not realize it. So, have you ever heard of the term rolling coal or seen pickups or similar vehicles blowing black clouds of smoke? That is a hazardous emission where you can fine-tune how much air versus fuel is entered into and pressure is entered into the engine, creating different amounts of emissions through the exhaust. Race trucks, like on a drag strip or whatnot, typically don't have DEF or catalytic converters, as that can reduce the speed of a vehicle. Smell, if you've been next to a diesel engine that uses DEF, after a cold start, it will burn through the system and smell like rotten eggs and make your eyes burn, kind of like the mixture of rotten eggs and chlorine. And like black smoke here can also smell, it's actually a more pleasant smell, I guess, if you like the smell of diesel fuel in the first place, because that is unburned diesel fuel and other substances. That can actually smell more pleasant than rotten eggs and chlorine. I drive a diesel car. I am required to put DEF in it as the system is in place. It's a newer vehicle. As soon as the warranty goes out for certain things, we will be removing the DEF, as it can increase fuel mileage and power to the engine without these regulations, or without those system regulators in place. Sources: Dieselnet, Cummins, Filtration, Google Images, and always thanks for watching.